Hello and welcome to video 3 of the Exponential and Log Functions video series. In this video we're looking to see how we can integrate exponential functions. When integrating exponential functions, we actually take the differentiation of the top and we put it underneath the expression to divide, and then we keep the top the same and we add c at the end of it. Let's have a look at an example. If we differentiate the top here, we get 4. So that comes underneath to divide the whole expression. So we get e to the 4x over that 4 plus c. You'll notice the indice of the 4x is still the same as it was in the original part of the question. And that 4, that's the differentiation of the top, has gone underneath and is dividing into the e to the 4x. In this second example, we could consider that to have a minus 1 in front of the x. So when we differentiate that indice, we get minus 1. So our answer here is e to the minus x, which was our original, over minus 1 plus c. This could also be rearranged with the minus out the front instead of underneath. But that's just another equally valid version. Moving on. Okay, we've got e to the 4 over 3x here. So the differentiation of the top is 4 over 3x. So we'll get e to the x, let's try that again. E to the 4 on 3x over 4 on 3 plus c. Now, you might spot that when we've got a fraction that is dividing, we can turn it upside down and multiply. So that gives us 3e to the 4 on 3x over 4 plus c. We've just multiplied by the reciprocal of the fraction that's underneath. Okay, here we've got 8x up the top, so the differentiation of the 8x will be 8. So our answer here will be 16e to the 8x over our 8 plus c, and I think you can spot where we can simplify that down by dividing 8 into 16 goes twice, so we get 2e to the 8x plus c for our final answer. Okay, here we've got a question asking for exact form, because unlike the previous ones where we had to add c at the end of our questions because they were indefinite integrals, these are definite integrals here because we have x values of 0 and 2 to help us be more exact in our answer. Okay, if we integrate this here, we have 4 as the differentiation of the top, so we'll have e to the 4x on 4 as our integrated version, and into that we are going to put x's of 2 and 0 and then subtract like we normally do with these definite integrals. Now we won't need to put plus c in this one because we have definite x values to process to a definite final answer. So when 2 goes in wherever there's an x, we have e to the 8 over 4, and when we sub 0 in wherever there's an x, we say e to the 4 lots of 0, which is 0 over 4. Now normally when you're subbing 0 in, the whole term disappears or becomes 0, but here we have e to the 0, which is equal to 1. So we have e to the 8 on 4 minus 1 on 4, because as you know, anything to the power of 0 equals 1 from our indice rules from previously. So seeing they're both over 4, another valid answer here would be to say e to the 8 minus 1 both over 4. Notice there's no plus c here because we're going to get an exact form. These are definite integrals right now. One slightly more involved question here, and this one asks for an answer correct to 2 decimal places. So we won't just leave it as an exact value or anything. We'll plug it into our calculator later. Okay. So let's integrate first. So e to the 4x, as we saw in our previous example, actually ends up being e to the 4x on 4, the integral of that. and plus the integral of this one will be e to the 2x over 2. And the 2x values we're going to process here are 2 and 1. So I'll be processing 2 wherever there's an x in this expression. We'll put a big minus, and then we'll process 1 wherever there's an x into these expressions. So when 2 goes into the top here, we get e to the 8 on 4, plus when 2 goes into the top here, we get e to the 4 on 4. Whoops, oh no, on 2 there, sorry. Just correct that. On 2, that's good. Then we have a big minus with a big bracket, just to be really careful with that one. Excuse the school bell going off in my background. Okay, now we're plugging 1 in wherever there's an x, so we get e to the 4 over 4 plus e to the 2 over 2. Alright, now to continue this, we could consider this to have a minus 1 here, and we might expand that through our brackets before we start simplifying too much. So that will give us e to the 8 over 4 plus e to the 4 over 2. When we expand this bit, we'll get minus e to the 4 over 4 and minus e squared over 2. Now we'll plug that all into our calculator, and if we're plugging it in right, there's a e to the x button in our calculator that we'll need to know how to work, and we'll use our fraction function of our calculator as carefully as we can. We should end up with 755.1945062 if we're doing it right, and it might continue there. So they want it to 2 decimal places, so we'll just round that off to 755.19 units, and the units will be squared this time because when we integrate we find the area under a curve. So that's integrating exponential functions in rounded form this time. We don't have any plus c's involved here either because we have the x values of 2 and 1 that we can plug in and make it more exact. Alright, that's it for that video, so thanks very much for watching, hope it helps.